Today we will discuss about the Rutherford model of atoms. Now let us see Rutherford alpha scattering principle first. We have taken a lead bulb and a radioactive sources, that means alpha particles was emitted from this radioactive sources, and when the emitter rays passes through a small slit means small holes, this slit is taken in order to reduce the amount of the alpha particles. Now the rays which comes from this slit passes through the thin gold coil. Why we have taken gold? Why we can't take the other species, other metal is that gold is the most ductile metal. So as much as you make thin shape, the atoms, overlapping of atoms should not be there. So you can get a clear pictures of this alpha particles. That is why we have taken gold coil. And then this alpha ray, when passes through this gold coil, majority of the alpha ray passes in a straight line. Only some amount, that is 1 out of say 12,000 rebounds back. 1 out of 12,000 rebounds back. And some rays deflected with the angle. Say we have seen here majority of the light rays passes, light rays alpha particle passes through the atom in a straight line, and 1 out of 12,000 return back, and some small amount was deflected with some certain angles. So this is what Rutherford alpha scattering principle observations. Then from this observation, that is Rutherford developed an atomic structures that we call as a Rutherford model of an atom. Now let us see how this was happened. Rutherford selected gold foil because he wanted a thin layer as much as possible. So the gold foil was about 1,000 atoms thick. Alpha particles are doubly charged helium. Alpha particle means it is plus 2 helium, 2 plus 4, mass number is 4. This is about the helium. So helium is there in the alpha particle, and they are fast moving particles having the considerable amount of energy. They are of fast moving particles having the considerable amount of energy, and it was expected that alpha particle would be deflected by the subatomic particles. Alpha particle will be deflected by subatomic particle in gold atom. Since alpha particle was much heavier than the protons, he did not expect to see a large deflection. So in order to prevent the large deflection, he used this gold atom. But in the alpha scattering experiment, what he was thinking, opposite of that, he got it. And according to him, the alpha particle may not deflect means that the alpha particle were not deflected by these gold atoms. But what he observed is that, number one, most of the fast moving alpha particles passes in a straight line through the gold coils. Number two, some of the alpha particles were deflected by the foil by some angles. And number three, 1 out of 12,000 particles appear to be rebound back. This result was almost an incredible one if you fire a 15-inch sheet at a piece of tissue paper and it comes back and hit you. Now, Rutherford concluded his experiment by saying that most of the space inside the atoms are empty. Because of that, most of the alpha particle passes through the goal point without any deflection. So, alpha particle move in a straight line. This shows that majority of the space inside the atoms are almost empty, and very few were deflected in their path, indicating that positive charge particles of the atoms occupy a small space. That means our proton occupy a small space inside the atoms, overall atoms. In the third conclusion is that a very small fraction of alpha particles were deflected by 100 atoms, were deflected reverse by atom. That means, which indicates that all the positive charge and the mass of that atom, that is goal atoms, was concentrated in a small volumes within the atom. So that means the space occupied by the positive charge is too small inside the atoms, which are to be negligible as compared to the overall space of the atom. So by concluding all this, she proposed the model which we call as a Rutherford model of an atom, such as first point for this postulate is that there is a positive charge center at the atom. There is a positive charge center at the atom, and that positive charge center is called as a nucleus. Nearly the mass of an atom resides in the nucleus. Nearly the mass of an atom lies in the nucleus. Why mass of the atoms lies in the nucleus is that heavier particles like proton and neutrons are in the nucleus. Proton and the neutron are in the nucleus. That is why majority of the mass are concentrated in the nucleus. And the second point is that electron revolve around the nucleus. Electron revolve around the nucleus in a circular orbit. Electron revolve around the nucleus in a circular orbit. The third one is that the size of the nucleus is very small. Size of the nucleus is very small as compared to the size of the atom. These are the Rutherford model of an atom. Now, let us see what are the defects of Rutherford model of an atom. The revolution of electron in a circular path is not expected to be stable. That means, suppose if we move around a table, then automatically, whenever you move, some energy will be lost. At last, you feel tired. And if you feel tired, then you will collide to the table. Then the table may be falls. Something like this one. If the electrons are rotated around the nucleus, slowly energy will be radiated or accelerated. Due to the acceleration of this one, energy will be lost. With the loss of energy, the orbit becomes smaller and smaller. At last, it will collide to the nucleus. If it collides to the nucleus, then nucleus becomes broken, the atom becomes unstable. But actually, atom becomes stable. So, that means it cannot explain the stability of the atom. This is what we have discussed in the drawback of Rutherford model of an atom. So we can read it again according to your book. Any particle in the circular orbit would undergo acceleration. Any particle in a circular orbit would undergo acceleration. During this acceleration, the charged particle were radiated energy. So due to the revolving around the circular orbit by electrons, we lost energy and then finally falls into the nucleus. And if there were so, the atom should be highly unstable. Atom should be highly unstable, and hence matter will not exist in the form. So matter will not exist in the form, but atoms are quite stable in nature. So this is what the defect in the Rutherford model of an atom. Thank you. Next time we will discuss about the Bohr's model of an atom.